Good day, everyone. I'm Bob Ackerman, the Editor-in-Chief of Signal Magazine, and I'd like to welcome you to our Signal Magazine webinar titled Automation, Key Enabler of IT Modernization and Cybersecurity. Many Defense Department network providers are being called on to decrease delivery times on speeds and feeds, deliver new capabilities to customers, and respond to ever-growing cybersecurity challenges, even as they face steady declines in IT budgets. To combat the issue of balance, the key to success is automation of the network environment. Automation reduces the time from detection to remediation from months to seconds, thus creating a more secure, more capable network infrastructure. In today's webinar, which is sponsored by Juniper Networks and Red Hat, three experts will explore how Defense Department organizations can leverage commercial best practices and automation to achieve mission success. Now, those of you who have participated in past Signal webinars know about our modern audience interface that offers useful capabilities. At the bottom of your console are a number of widgets, especially the green Resource List widget, which you can use right now to download slides from today's webinar, along with company links and a topic-related video. Most importantly, throughout the presentation, webinar attendees are encouraged to submit questions electronically through the Q&A box on the webinar console. When our experts are finished with their presentation, they will answer as many questions as time permits during this hour-long session. Today's first presenter is Dave Michalczyk, Head of Federal Strategy and Technology at Juniper Networks. Dave joined Juniper earlier this year after spending 18 years at the Defense Information Systems Agency, DISA, and the last 12 as Chief Technology Officer. At DISA, he established the agency's board for facilitating and governing cross-program integration and synchronization, and he developed the Defense Department's enterprise-wide systems engineering process and plan. Our second presenter is Martin Smihula, a senior consulting engineer with Juniper Networks. During his 10 years at Juniper, Martin has held a multitude of roles supporting Fortune 100 companies. Currently at Juniper Center of Excellence, Martin previously worked for 15 years connecting and securing premier casino destinations along the Las Vegas Strip. Our third speaker is Lee Kinzer, Senior Specialist Solutions Architect, Red Hat. Prior to joining Red Hat, Lee worked in information security and Linux systems engineering with SPAWAR-LANT for more than 8 years. With Red Hat, he has worked with the Defense Department in support of the company's emerging technology portfolio, with specific focus on cloud and automation technologies. So with that, I'd like to turn the presentation over to Dave Michalczyk. Dave?
So thanks, Bob, and thanks for inviting us all today. As you said, my name is Dave Michalczyk. I'm the Federal CTO for Juniper Networks, but up until about 10 months ago, I was a career civil servant, and among other things, I built tactical systems for the Department of the Navy while at the Naval Research Lab, and built a long-haul communications network for the Defense Information Systems Agency, and for about the last 10 years of my government career was the Chief Technology Officer of DISA. So I'm going to talk a little bit about the need for network automation because in my former life, it was one of my top priorities. So what's the challenge that CIOs and system administrators are facing inside the Department of Defense and the federal government writ large? As your IT budgets are shrinking, your demands are growing. The customer's expectations rise. They see what can happen in commercial technology, and they have those same expectations of their government technology. And at the same time, we're in the middle of a cyber war that's been going on not for years, but for decades. You cannot afford to leave your network open to cyber adversaries. So there is an opportunity, and that opportunity stems from the fact that the government spends as much of its IT budget on personnel as anything else. It spends 80% of its IT budget simply maintaining existing services, keeping the lights on. So there is an opportunity to flip this number, to try to take advantage of automation, to reduce the cost of operating and maintaining existing networks, to have funds to invest in network automation. Network automation. So I like this very simple definition. It's the process of automating the configuration, management, testing, deployment, and operations of both physical and virtual devices within a network. It can improve efficiency, reduce human errors, speed service delivery, and certainly reduce operational expenses. So automation is all around us. If you have experimented with home automation, you probably are using something like if this, then that, to cause events that occur in your home to be detected and then cause other actions to be taken, such as the sun going down and locking your front door. We've all seen the news stories about automation, self-driving cars. This is the wave of the future. We are going to see self-driving cars on every city in this nation probably within the next 5 years. And certainly in a variety of industries, automation is the standard approach to reducing operational costs and increasing customer service and capabilities of product lines. So federal IT managers, I've got news for you. You don't have a choice in this. This is a quote that I found from Tom Preston Werner. He's the founder of GitHub. You're either the one that creates the automation or you're getting automated. So federal networks will be benchmarked against commercial networks, and commercial networks are automating today. This is something you have to embrace or you're going to go out of business. So what we want to focus on today are the technology aspects of network automation. Now, culture and process are also critical to successful network automation events, but we're going to save the discussion of those for another day. So with me, as Bob mentioned, I've got Martin Smahulu, who's a Juniper Networks Senior Consulting Engineer, and he's going to talk a little bit about the interfaces, standards-based protocols, and best practices for achieving event-driven automation, and even walk you through a real-world example of how that can happen. And then finally, Lee Kinzer, a Red Hat Senior Solutions Architect, is going to discuss Ansible, which is one of the most broadly deployed platforms for IT automation in the world. So with that, I'm going to turn it over to Martin.
Thank you very much. Thanks for everybody for joining today. So I want to start out, I think most people agree that our industry is undergoing a transformation and that automation is a key component of that. Many other industries have undergone transformation where automation was key. If we think of the auto industry, both from Henry Ford and the assembly line, what that did 100 years ago, up to today, as was mentioned about self-driving cars and how automation plays a key part of that. In our world, in the networking world, we're being asked to do a lot of scale up, but we're not necessarily given the resources from a people standpoint and everything to meet that type of requirement. So the only way to get there is going to be automation. If we break down kind of where we've been and where we see automation going, we can start out with kind of a day zero, and this has been going on 20 plus years. This is kind of the human part of automation where we manually run a script, so that adds a lot of value. That keeps us from having to type commands over and over again and this type of thing. However, it doesn't do the same things that we'll call day one or event-driven automation. This gets us to the next level. And if we're going to get ourselves to autonomous networks, we're going to need this if this then that type of decision engine that can react to events in the environment and go ahead and automatically take actions instead of waiting for a human. So if we think about routing protocols, right, this is event-driven automation. We don't wait for OSPF when it finds an error or a link down that it needs to reroute traffic for us as the operator to go ahead and acknowledge, yes, go ahead and make this change. It makes the change and it notifies us after the fact. These are the type of things we want to try to get to from both provisioning and from an operations standpoint. And then lastly, this idea of self-driving cars, it's been supposed, what about a self-driving network where we can leverage things like machine learning that can help us generate the rules to decide what to react to and that type of thing. That's pretty far out, but we think event-driven automation in the day one is achievable today and can add a lot of value with the tools we have. So if we look at the tools that are used around day zero automation, we've been doing for a long time things like screen scraping with Perl, logging in with SSH. More recently, more of a structured approach where data is either JSON or XML encoded and we get to it via a programmatic interface like REST, netconf. That's added a lot of value to be able to extract data, push configurations, and really helped. Then also look at tools like Ansible that provide us an abstraction layer that simplify this so you don't necessarily have to be writing Perl scripts or any more Ruby, Python, those type of things. Now we can look at more of Jinja 2 templating, YAML configuration files, and still get a lot of the same benefits. However, this is still kind of a push button, person clicks, executes the playbook, and so on. So we can illustrate this in just a simple common automation process where you have some sort of network management system in step one where an alert is generated. That operator needs to react to that alert. Here in the slide, the time is 3 minutes. That time could be arbitrary. It could be less. It could be a whole lot more. And in some of the breaches that have happened in recent times, that operator, unfortunately, those operators never did see that alert based on the noise of the number of alerts that were coming in, right? Once the operator does see the alert, that person now needs to turn around and, previously they would actually log into each of the networking devices or the servers, whatever the case may be, to gather data about that alert and move forward. We've done a lot in the last handful of years to go ahead and just prepare scripts, add some input values. It would go off and actually interrogate the operating entities, bring that data back, and then the operator can sift through that, look for the relevant information, and open up a ticket. That's going to take some amount of time. Slide says 11 minutes. Could be less, obviously. Could be a whole lot more in common scenarios. So if we look at kind of day one, the event-driven piece, the tooling now we add on to that, right? So we still use the same tools as we saw before. We still use things like REST interfaces and netconf, Ansible, those type of tools. However, now we layer on top of that something like a message bus with RabbitMQ. We also need something that can do a little more intelligence and analytics against our telemetry data that is coming in. So for example, Juniper's AppFormix could do that. But now we're actually being able to see events, sift through all the data that gets generated, which can be hundreds of thousands or even millions per day, and then have some sort of meet me place that we can make a decision engine that decides what do we want to do about this in real time. So if we take our same automation process example that we saw before where the human was doing the driving, and now we allow automation scripting to do that, that same network management system is still going to generate an alert, but now it's going to, instead of the human waiting for it, it's going to send it to an event bus. That event bus can have a decision reactor engine that can go through and have a series of rules, and what sees a certain, like a link down or an impairment, say maybe on your border connection, it knows what script and what parameters to take to go out and gather the data that's required to do more analysis, and then can automatically open up the ticket. So whether that's 1.3 minutes as shown on the slide versus the 11 minutes in the human standpoint, those times can obviously be different, but it's pretty safe to assume that the automated process is going to be much quicker than the human-driven process and will be less error-prone, assuming our rules are up to snuff. So what does it take to actually build an event-driven infrastructure? I have a few components shown here on the slide. The first step is this idea of shifting your mindset and thinking about things as a declarative state. So this is more of a what versus how way of thinking. And so now we say that the configuration, the network should look like this. We want to do things to go out and enforce that that's the way we wanted to see it. So it may not sound like a big shift, but it definitely has ramifications as you build your automation. The next piece are event sensors. This is the entities that are in the network that are going to generate telemetry information. This is what's going to let us know things are going on. And that could be firewall rules as logs. That could be just SNMP type data coming out on link status. Whole host of environmental entities that are going to send that data up that needs to be processed. And the idea is we have some sort of shared event bus that's going to collect that. Now, whether all that information goes directly to the bus or goes to some like a SEM that would filter through and then figure out the important events and put those on the bus, eventually we need to get it into our decision engine that's going to decide what to do. And the actions that are taken we call reactors. This is where we actually have the API code that's going to interface with the endpoints that we want to make changes to. And there may be multiple. It doesn't mean we're just going to make a single change to a single router, say. There could be a whole host of things that need to be changed as part of this process. So here's a sample topology, and obviously this can be architected many different ways, but some of the core tenets will be what you see in the middle of this EDI event bus. We also call it an automation backplane. This provides your integration between your different systems. So instead of having to build an interface between your ticketing system and your SEM and your ticketing system and your config repository, all the different pieces that need to talk, they just now need to be able to communicate with the event bus. And now if you change out, let's say you have, we're going to show request tracker in our demo for a help desk system. If you change that out to remedy down the line, no one else needs to know except a new interface needs to be built for the new ticketing system, but all the other systems that would communicate with that, like your orchestration system, still communicates with the bus the same exact way. How that data gets into the system is just one new interface instead of having to touch everyone. So we see at the bottom of the slide are our telemetry generators, and those are typical things that we think of like routers, firewall switches, servers, storage systems, all the things that we think of as infrastructure for the most part. We can also look at, as that data comes up, it could be sent directly to the bus, as I mentioned before, or it could be sent into one of the systems that we see more to the top that tends to do more processing, more interfacing with us as humans. And then finally, at the very top, we have some sort of orchestration system. Now, that could be a full-blown business logic, could be a customer portal, or it could be simply a ticketing system that we're going to track our work through, and that's what we'll see in our demo here coming up. So the last piece of kind of the event-driven infrastructure is what we call reactors. So once that information does come into the bus, we have a rules engine that looks for specific events that come in that's going to say that this is something that bad happened in the environment, like a link went down, or it could be work that was submitted that was put into the system through a work order, ticketing system, and so on. Somehow the rules engine is going to look at that and say, okay, that maps, based on that event that came in, I'm going to map that to this action that I want to take. That action could be an actual Python, Ruby type script. That could be an Ansible Playbook. It's something that's now going to go out and take action to make changes in your environment. And as I said, those could be multiple changes, as we'll see in our demo. So how do you get started? So as I mentioned, that decision engine is kind of an if this, then that model. And something that's linear, it's very simple in the sense of I see the link to the internet connection go down, I take this action. Those are a great place to start. And it could be simple as I don't want to actually change things on my router. I just want to be able to automatically open up a ticket that can be tracked, right? So you can start with a more of an informational model, and then as you get comfortable, start to move that. You can propose what that change should be as part of the notification. And then once you hit critical mass where you see things that have been working well, you can go ahead and move on and actually automatically take that action. The other characteristic of the event-driven infrastructure is this, what we call yet another single pane of glass, right? Who really needs another system to learn that's supposed to be an overarching system that will integrate with all your existing systems? The idea here is if we just have the event bus, or why we call it the automation backplane, glue these entities together, we don't have to go back and have to have our people learn a whole new system to do the same job that they already have a system that does that well. So in the Juniper world, something like Junospace, you don't have to go through and actually replicate all the functions that Junospace does. Now you just glue them to your customer portal, your ticketing system, maybe if you have the orchestration, whether that's VMware for spinning up virtual machines, whatever that may be as part of your workflow, you just have the bus glue it together, and now people don't have to learn new things. You just extend, say, the ticketing system to be able to put work into it, or your business logic system you add a new screen to, but it's something that your operators are already familiar with. So we've gone through and we've talked about what event-driven automation is, some of the pieces, parts that make it work. Now I want to set up for a quick demonstration of onboarding a new device, which is a common process. Like I said, in the Juniper world, yeah, we may just bring that into Junospace. We may have to put an initial configuration on there. However, now you would have to go into a different system, maybe to do your telemetry collection. You may have to get that into an inventory management system. These could be all different systems that person would have to go from one to the other to the next to make happen. Here we're going to have a single event that shows the data hit the bus. And then from that, we're going to spawn the multiple actions that bring this new device under management. So here we see that the zero-touch provisioning isn't just bringing the device up. We have a 47-step mop here that we have this Gen Telco as an example that would have to go through to onboard this new device. So we're going to call this ACC0101, and we need to bring this under management for our NMS, telemetry, infrastructure as code, and so on systems. So we have a couple of systems that we're going to interface that are going to provide us feedback. The first is Request Tracker, or RT4. And so as an action happens, a ticket is going to be generated or updated to reflect that. We have Juniper's AppFormix, which is a telemetry and analytics system. We can see here we have two devices right now. We're going to be adding our ACC as a third. Junospace is our network management system. Again, we see we have two devices. We're going to add the ACC device as the third. Lastly, we see here that we have an instance of GitLab that we're going to use for configuration management. We have our existing two Core 0, Core 2 routers, and we're going to be adding our ACC router as part of this. So we're going to have a single event kick this off, and based on this event, when it hits the bus, which here we're just showing basic JSON, that's going to invoke multiple actions or reactors. So on our actual VMX, there's going to be a base configuration that's going to be added around management in our case, just as an example. We're going to add an external syslog server. We're going to add a Gen Telco user to be able to do our access method. And we're going to add SNMP configuration. And we can see none of that is there yet, right? So when the event hit, it generated a ticket into our request tracker system. And we can see that our new device, ACC0101, is now online, and it has the 192.168.122.4 address. Now what's happening is we're spawning the other things to get under management. So our initial configuration was pushed down to the device that's going to add our SNMP, syslog, and so on. So we can see that the ticket was updated with that. And we can see that GitLab also now has the configuration backed up as part of that onboarding process. We can see ACC0101 was added. And if we dig into that, we can see that the configuration, and what was added was built from templates, Jinja 2 templates. But as we scroll down, we can see that we have SNMP. We just added a community of public for read-only. We can see under our system syslog that we have an external syslog server that was created, and we can see that our login user, Gen Telco, was added. So that's the next step of the onboarding, and these things actually happen in parallel. We have our network management system, Junospace. We can see that another task of this onboarding was to get that brought under management, and so we can see it synchronizing. So the operator didn't have to go into each of these interfaces and manually do this. Our onboarding operation scripts are actually doing it for us. We can see that information reflected in Request Tracker. So now for the Junospace device discovery, the ticket was updated. And we can see the Junospace job ID at the bottom, that 262177. We can use this if we need to go back to Junospace to get more details about the onboarding process inside of Junospace. For our app formats, our telemetry collection, we can see that ACC0101 was added, and now we can start to collect SNMP statistics and start doing an analysis against that. So that was one workflow, and now as an extension to what we had, we get this kind of for free with JEDI to be able to go through and do config compliance. So the example we're going to add here is adding set system services telnet. You can see by rule, telnet is not acceptable. So the operator goes in, they can add it, right? So we're going to go ahead and do our commit. And when we see that, that's going to kick off that backup process automatically. So every commit backs up to GitLab. The compliance check happens, and because it's out of compliance, it goes ahead and generates a new ticket inside of Request Tracker. And if we go in there and we look at it, we can see the rule that failed. In this case, it's called test telnet. We can have multiple rules that we can check against. And if it does, we can automatically remediate to remove telnet. So we still keep the other changes potentially as part of that commit. We just remove the offending configuration, which in our case is telnet. We can also see that reflected inside of GitLab. So if we go into our configuration, we go ahead and do a comparison. We can see in the red that telnet with a minus sign, that was removed. And we can also see that by the latest config backup when we made the change and it was automatically remediated. As we go through under our system services, we can see only SSH and netconf. There's no telnet listed. So hopefully that was, I know that was fairly quick, but hopefully that shows you some of the capabilities that are available with event-driven automation, whether we're putting work directly in through a ticket or there's an event that happens in the environment, how quickly and how we can string workflows together to be much more cohesive and not miss options. Okay, so if that's our day one event-driven automation, what's the future? You know, what comes next? I mentioned if this then that, right, is good for EDI. However, if we get into more of a more complicated decision structure, if this and maybe this, but also maybe this too, then that, now we're starting to push the bounds of what EDI can provide. And now we're starting to think more of leveraging something like machine learning, where we can start to look for patterns. It can start to suggest actions and rules. And this kind of gets us to this nirvana of a self-driving network where we can have something that's much more autonomous than just day one automation. So EDI or event-driven automation, one of the key components is we can leverage the scripts we already have today in Playbooks and all the good things that have been going on the last handful of years. We don't have to get rid of any of that, but now we can up-level it, and we can start to react to things dynamically going on in the environment instead of being the impediment and the roadblock. That also allows our operators to up-level their workflows, so now they don't have to sit there and do some of the menial tasks of just opening a ticket. They can be much more reactive. They can backstop what the automation is doing to make sure that it's collecting everything, improving the rules engine, and now they can look at offering additional services and being more proactive in what we're doing with our customers as opposed to just reactive. So hope that was a good introduction to EDI, and now I'm going to pass it over to Lee to talk about Ansible from Red Hat.
Thanks for that, Martin. And from the Ansible and Red Hat side of this, we can look at how Ansible can play as a component inside of this automation and orchestration that the folks over at Juniper are working in, where they're putting together these larger workflows, but still utilizing some of the automation scripting and things that are built into Ansible to not only automate some of the processes that are happening inside of the network infrastructure, but also maybe stepping outside of that, looking at things that might need to happen elsewhere in the IT infrastructure in order to support a larger overall automation workflow. So to begin with, what is Ansible for anyone that's not familiar with it? It's really just three different things, right? First off, it's a simple automation language. It allows you to describe in a declarative fashion what you want the endpoint that you're managing to look like, what configuration we want that to be in, and what state we want it to be in after any Ansible run has finished up. That's also a very simple language, very easy to understand, very easy to read. It doesn't really require you to have any kind of advanced programming knowledge or experience in that kind of area. Next up, and kind of the biggest underpinning behind everything, is that it's an automation engine that takes those playbooks that we've written. Those playbooks, by the way, are all written inside of YAML. So we take that information in, and we then execute that through the automation engine. That's actually the component that goes out then and affects change inside of the environment to put whatever those desired configuration changes are in place on whatever devices it is that we're managing. Then beyond that, we've got Ansible Tower, which acts as kind of the enterprise framework to wrap around all of this underpinning of the automation engine that provides the back-end side of all of this that's actually going out, touching the devices, making the changes to it. Ansible Tower is kind of that front end that we interface with from a user perspective and from an administration perspective to set all of this up, give us a nice user interface to interact with, as well as a RESTful-based API in case we have other systems like the folks at Juniper were just talking about that want to be able to make calls into the Ansible environment to kick off certain job workflows inside of there. And so kind of the three distinguishing characteristics of Ansible that we like to talk about is that it's simple, powerful, and agentless. First off, the simplicity comes from the human-readable nature of the automation language itself. The playbooks are written in a fashion that abstracts away a lot of the complexity of what's happening underneath the covers for any given automation job that we're running. So it doesn't really require a lot of special coding skills or anything like that in order to get up to speed quickly on how to develop the automation and then how to use the automation inside of the environment. Beyond that, it's very powerful in that it is truly extensible. So Ansible really leverages its power based off of modules that we have written and the community has developed to go out and make changes on various different components, whether those be software, hardware, or quote unquote other, that we're going to be working with to make changes on. So those modules take away much of the complexity of dealing with any one of those specific devices. For example, there are a number of Juniper modules that exist for going out and making changes on Juniper devices. There are obviously Red Hat modules that exist for going out and making changes on RHEL-based systems, Windows-based systems, whatever those may be, that take away a lot of that complexity. And that really gives you a powerful stance over the environment because you can be able to develop automation quickly without having to worry about getting in a rabbit hole of developing this very complex automation scripting language. Beyond that, it's also agentless, so we don't have as many restrictions where we can run Ansible and what type of devices we can manage. Essentially anything that we can SSH into and get to a command line on, we can manage. If it's a Windows box, we can use WinRM to interface with it. Any other software platforms and things like that, we can access their API, as well as I mentioned earlier, right, they can obviously access our API. But any of those three, right, whether it's SSH, WinRM, or some type of API, we can reach out to all of those and automate and orchestrate across any tooling or hardware or software that we have inside of the IT infrastructure to be able to affect change on those devices. So let's talk a little bit about the Ansible architecture itself and how it's laid out. So there are a number of different things on the screen here. We'll try and step through them one at a time, and everything kind of starts with the playbooks, right? We mentioned those earlier. They're all YAML-based, very simple, very easy to understand, and that's really where all the design work goes into stating how you want the device or the endpoint to look after this Ansible automation run. That's also where we call out to the modules, and those modules are kind of what we consider tools in the tool bag that we can use to go out and affect change on the various different type of devices that we have inside of the infrastructure. If we don't have a module for anything that exists inside of the infrastructure, maybe there's some type of device or endpoint that is very unique or specific to your environment that maybe not many others use, we can use generic modules and just be able to send direct raw commands to those end devices to manage them. But generally, it's the case that there are modules that already exist out there that are going to make the work that needs to be done on whatever that endpoint is a whole lot easier. So once we've got our playbooks and our modules, we then need to know what we're going to execute against, so what devices we're going to work against, and that comes from the inventory. So there's a couple different ways we can pull inventory into Ansible. First off, we can do that with just static files, right, where we just manually define the endpoints that we're going to be managing. We can manually group those together into various different groupings that we might want to use for deciding where we're going to execute any of our given pieces of automation. Or we can pull that from some dynamic source, right? So that dynamic source could be some form of CMDB, right? Maybe we've got a Postgres database that we keep track of all of our routers and switches in, and we want to be able to query that information out of it. We can do a query out to that custom CMDB, pull that into the inventory, and automatically group that however we need to based on data and fields that we can pull out of the CMDB. Or if we've got systems running inside of VMware, Amazon EC2 instances, we want to manage those with Ansible, we can have those pulled in as well, even if there's something inside of a private cloud infrastructure. So maybe we just want to pull from VMware, Rev, Microsoft, Azure, or something like that. We can pull in from any one of those different sources, populate our inventory with that, and construct our various different groups from that we can then execute against. And obviously then the API that we talked about earlier allows all of this to be accessible from outside of the Ansible interface. So in no way do we have to be inside of Ansible or inside of Ansible Tower to execute any of these automation jobs, even to make changes to the automation jobs, changes to inventory. All of that is accessible externally and can roll into a larger process automation workflow like the folks over at Juniper were discussing and talking about. And then plugins help extend that even further. If there's some maybe corner case type of functionality that's necessary inside of Ansible, we can actually extend that with new plugins. We can also do that with modules, right? Those can be extended as well. So if you have things inside of your inventory that you need to be able to interface with, you need to be able to manage, or you need to be able to extract data out of, we have flexibility inside of the infrastructure to be able to build out modules for doing that, or build out plugins to extend that capability inside of Ansible and inside of Tower itself. So now let's look at a quick playbook example that'll kind of show what it looks like to write some of this automation. And in this example, we're going to look at a quick little playbook for making some changes on a Junos-based device. So first off, up at the top, we'll see a name field there. This is really kind of self-documenting code. It allows us to easily see what each section of the playbook is going to be attempting to do. We can see in this one there are a number of different name fields here, from upgrading the device and configuring netconf to upgrading firmware, setting hostname and login banners, multiple different name fields there. And as we execute any one of these Ansible playbooks, we're going to see all of this in the output. So whenever we see job output coming back from the endpoint that we're managing, right above that we'll see the name of whatever the thing is that we just attempted to execute. So we kind of know if we see maybe a warning or an error or anything, what section of the playbook we were attempting to execute when we ran across that. The next directive there is going to be for host. This tells the playbooks which endpoints we're going to run against. This one is set to run against all hosts that we have inside of the inventory. We could easily change that to any subset of hosts that we wanted to run against. Maybe we only want to do it on a certain edge router, or maybe just firewalls and switches that live inside of the DMZ. However we want to distinguish what endpoints we want to run against, we can denote that right there in the host. Next up, variables. Variables can be defined in a number of different ways. Here we're defining them statically and just saying, hey, here's this port that I want to be able to use later in the playbook. I want to be able to define it once, then maybe reference it multiple times throughout the rest of this playbook run. We can also pull those variables in from source files. We can gain variable data from previous playbook runs. So maybe we want to go out to an endpoint or a device, query information off of that, and then use that information to populate the variable that we're going to then use in a later playbook run. We can do that as well and kind of have it be dynamic information that's never statically defined, just something we go out and query from the devices and then use that as input to the future playbook runs. After that, under the task section, that's where the heavy lifting actually gets done. So there are a number of things in there. You'll see the one for Junos install OS, Junos netconf, and then Junos config. Those are the various different modules that we're calling out to. So we're actually calling out to Junos-based modules that are going to perform specific functions And after we call that module name, we then just pass it a number of arguments that tell it what state we want the system to be in after that module has run. So for example, in the Junos install OS, we just simply tell it the version of the OS we're looking to install, the source directory and location of that installation file, and then whether or not we want to reboot the device after we're done installing it. And there's a lot of complexity that happens on the back end there. Right? That module handles moving and transferring that file over to the device, putting it in place and setting it as the operating system that it's going to boot to the next time, and then rebooting that system, waiting and making sure it comes back up, and then reporting back to the user on whether or not it was successful or a failure, going back in and making sure it's actually running that version when the system comes back up. So there's a lot of complexity that's happening underneath the covers, and that means that the end result in the playbook is that you have a much less complicated list of automation here, rather than so verbosely going in with something like Bash or Perl and having to tell it exactly every single step and every single command that's necessary in order to achieve that goal. A very similar thing here with configuring netconf, and then a little bit different when we get down to the Junos config, where we're actually sending raw commands. So this is one of these examples where maybe there isn't an existing module that's out there for setting the host name or setting the login message, because that's a very tiny and specific thing. We can just send generic commands out to the devices to have it set those things. And it's worth noting that this is specific to Junos, but we could do this with anything else as well, right? Maybe there's a Linux box that we're managing, or a Cisco device or something like that. We can throw commands out to any of those as well. Just send those raw commands to it and have it execute whatever that is, report it back to us in the logging that we're going to hold inside of Ansible on the back end. So everything we've been talking about so far is really just talking about the automation engine itself, kind of the underpinnings behind Ansible, not really the front end that you interface with a whole lot. That front end is more around Ansible Tower. That's where we give the really nice graphical user interface and everything. So let's talk about that for a little bit. And so Ansible Tower builds upon this existing foundation that's a simple, powerful, and agentless foundation. It does that by adding on, first off, control over those Ansible job runs that we have out there. We can centralize all of those in one place. We can see all of the data from those job runs in one place and be able to control them from one location. Beyond that, we can add delegation with role-based access control to control who can access those jobs, when they can execute them, what entities and endpoints they can execute them against, and provide all of that in a self-service portal where those users can see their endpoints that they're responsible for, the jobs that they're running, and the output of those jobs. And then from an administrative perspective, we get knowledge and visibility into that to be able to see a historical view of every job that we ran, what that automation looked like, what changes affected the environment, and whether they were successful or a failure. So kind of to reiterate here, Ansible Tower is that enterprise framework that wraps all of this around the underpinnings of that Ansible automation engine. And that provides us, again, with that UI and that RESTful-based API to hook into larger automation orchestration or other workflows that already exist inside of the environment. And if there's something you've already built out or something that you're already using for providing automation or workflow inside of your existing environment, you can just simply call out to Ansible from that using this Ansible Tower API and be able to execute directly from there. And again, all of that, including even the RESTful API calls, are all based around role-based access control, so we can have multiple different people, multiple different groups logging into the infrastructure and only seeing those things that they have access to and only being able to affect change on the things that they have access to. Again, holding all of that in one central location, logging all of it, and being able to give you a single point of administration for controlling access into the entire automation environment. We also have the construct of workflows inside of Ansible Tower. We kind of mentioned some of those earlier when Martin was talking, but we have that same construct and concept inside of Ansible Tower. So we can have various different groups that might be responsible for different pieces of the automation, right? So we might have one group, for example, that controls deploying virtual machines and operating systems out into your virtual environment, and then a completely different group that handles setting firewall rules and controls, maybe setting new DNS entries, interfacing with Active Directories, set up new user accounts for systems that are going to be deployed. We can have each one of those independent groups manage their own playbooks and their own job templates, and then string all of those together in one workflow that also has decision trees in it, so that if at any point in there we see a failure, we can take some different action based on the output of that failure. Right? Maybe if we're running through our workflow, we get through deploying the VM, making changes to the network that's necessary, and then when we get to the point where we need to allocate storage, there's some type of error, we can then stop, go create a ticket in whatever our ticketing system is, and have someone come and look and see what happened to that automation workflow. And guys, that's really it for me. I think at this point I can turn it back over to Bob and let you kind of wrap things up.
Okay, thank you, Lee. Now we have our question period, and we already have some questions in the queue, but I want to remind everyone, feel free to ask any questions you want. Use the Q&A box. That and only the Q&A box is your portal to get questions in to our panelists. Let me start with one of the ones that we've already received. And the question is, we have systems that are not always connected. For example, we have mobile systems that will not always be able to connect to a bus. How does EDI work in these environments?
Martin, you want to take that question?
Sure, this is Martin. So generally, we're able to maintain state locally on those remote systems. And with that, what we can do is when the system does come back online, we'll record its last state that we saw it, and then when it does come back online, we can get its new state, and we'll just use that once it's reestablished and the master comes up. So generally, that's the way we approach it. Depending on the environment, though, we could look at other ways.
Okay. Another question. Are there any forums or standards for how to automate, or does every network require working with each vendor in their network and then figuring out what is required to automate?
This is Martin. I'll take that one as well. So the short answer is kind of. There are standards bodies in the sense of trying to build an automation platform. So there's the ONAP, Open Network Automation Platform. I believe the Linux Foundation now maintains that. However, usually what will happen is you're looking for, you'll most likely have a multi-vendor network. You're looking for interfaces that will use a tool like Ansible, and you're looking for how it will be able to interface with those endpoints. So things like REST is a very common access method, and netconf is another. You're looking for somebody that provides those type of interfaces to you that you can then tie into the automation tool of your choice. You're also looking at those tools like Ansible that go through and have already a lot of that work done for you. So from the Juniper perspective, there's a Junos module for Ansible. It does all the heavy lifting as far as how to communicate to Junos devices, to make configuration changes, has a bunch of pre-built functions. So generally, you're looking at both sides of the equation for that. What does the endpoint offer on how to access it through standardized methods, through standardized access to the data, whether that's XML or JSON, or the two most common, and then the tools that you're using. If you want to go through a more standardized, then maybe something like ONAP would be worth your time.
Okay. Got an Ansible question here, so I guess this is your bailiwick, Lee. Is Ansible Tower capable of running in classified or otherwise disconnected environments? If so, are there any caveats to installing the software in these environments?
Yes, so we can certainly run Ansible inside of any kind of disconnected environment. It doesn't really require any connectivity to the outside world in order to be able to function. We've even got special installation packages that bundle together not only the Ansible Tower installer, but also any of the dependencies and everything like that that are associated with the Ansible Tower install and the underlying Ansible automation engine, so that all of that's wrapped together and can be installed completely in a wholly disconnected environment. That includes all the modules that are required for managing the various different endpoints, as well as all of the supporting libraries and things like that for the front-end application as well.
Okay. Lee, you're being inundated with Ansible questions. We have another one. You mentioned that the Ansible community has developed a number of modules, but what about playbooks? Are those community developed also, or will developing those be our responsibility?
Yes, so with that one, it's a little bit of both. Ultimately, development of the playbooks is the responsibility of the end user, because you are the guys that are going to know, what needs to happen inside of your infrastructure and exactly what automation you want to put in place and what endpoints and types of devices you want to interface with. However, there is Ansible Galaxy, which is kind of a user-driven community that has a number of various different playbook examples for a lot of common use cases, right? Things that would be most frequently used inside of an IT environment, you can almost certainly find on Galaxy. And we find that most people will generally pull some examples from there and use that as kind of a baseline to start when they start developing their own automation.
Okay. Now we have an EDI question. I do not want to rebuild all my automation scripts. How do we use our existing automations that are already in use today with EDI?
Yes, Martin. So the nice thing about this, as I mentioned, with that message bus being the glue in the center, the reactor, when it actually takes the action, that is where you implement this thing you're already doing today. So, for example, if you have in that workflow that I was talking about, if your action or if your problem is a link goes down and you want to gather information about that router and so on, and today you have an Ansible playbook that does that, you still use that Ansible playbook. It's just now invoked through the rules engine as part of JEDI. So you don't necessarily have to rewrite your scripts or write them in some other language or anything like that. It's just now how do we kick off what you already do manually as the human-driven and tie that into the event piece.
Okay. Lee, I think we'll go back to you for another Ansible question. Can multiple Ansible Tower servers be configured for redundancy?
Yeah, absolutely. So we can do that in a number of different methods. So we can simply have redundant Ansible Tower servers where we just synchronize data between those, right? Maybe separate those geographically, and then just share data between one another so that if the primary ever goes away, the secondary can just simply pick everything back up, right? It has all of your users, all of your permissions inside of it. Any integrations with other systems, maybe if we want to tie that in with a Splunk log collector and Active Directory for LDAP-based authentication, we can have all of those configurations sent over to the secondary, and it will just pick up operations as soon as the primary fails. Or we can do it in more of a type of distributed environment. Maybe we want to place Ansible Tower servers in various different locations that are going to be closer to the endpoints that they're going to be managing, and then synchronize data between all of those. We can certainly do that. And then whenever we kick off a given job, it will actually get distributed out to the Ansible Tower server that's closest to the endpoints that we're managing, and then push the jobs out from there. And that's a manual delegation process, right, where we figure out which ones we want to use for acting on whichever pieces and groups inside of the inventory. But we can certainly have a distributed environment like that where we're not reliant on any one tower server, and if that one goes away, we're kind of in trouble.
Okay. All right, we're back to an EDI question. You state using your existing systems to integrate with EDI. How does EDI connect to my existing systems?
So most modern applications have some sort of API, most commonly REST. And so we would connect through the REST API. So for example, Juniper products, things like JunoSpace, AppFormix, these all have REST APIs, and we just make the call into the REST API to gather the data or to push the change. Other systems, things like OpenStack and VMware, both have REST APIs. Both give you, all the functions essentially that you do through the human interface. You can do that through the API interface. As a worst case, we can do kind of screen scraping SSH where we push data in. So if you have an older router or something like that doesn't support that, those, brush off those old Perl scripts, and if you're still using those, we can tie those into. So basically, however you're programmatically getting into things today, we would just leverage that. And if you're not into getting into it programmatically today, and especially if it's a relatively modern application, we would just leverage the REST API that comes with it.
Okay. Martin, I think this one is in your neighborhood. Someone asks, I need to share state information between different classification networks. For example, a SIPR device needs to know that a common access router is not available, but we cannot allow the system to talk to each other via TCP. How could you get state information between the classification networks?
So the nice thing is that's what the message bus is designed for, is to allow communication like in a publisher-subscriber type of scenario, where you can get information to the bus, and then whoever needs to extract or access that information can get at it via the bus, right? And that's all rules-driven. So it doesn't mean it's only the people that are registered and allowed to get to that data would be able to get to the data. It's not published to everyone by any means. However, that meet me in the middle, that integration mechanism is there. So you can have an EDI network in each of the different classification networks. The JEDI, what we've offered is it has a kind of a built-in syslog engine. So one way you could do this is to go ahead and that would allow you to send the syslog message, essentially a unidirectional delivery mechanism onto the bus, and then those that are allowed to subscribe and access that, or the action that is taken based on the reactor, would allow essentially the filtered communication to happen based on rule.
Okay. Lee, here's one for you.
Hey, Bob, before we get to that,
yes.
Dave Mihelsik, I'm sorry to interrupt. I just wanted to elaborate on Martin's answer. In addition to being able to pass those unidirectional messages between buses, some sort of approved cross-domain solution would be required. There is a standard catalog of approved solutions, and in fact, DISA, the Defense Information Systems Agency, even offers cross-domain as a service. So as long as the messages can be routed through the cross-domain enterprise services, they potentially could be easily passed between multiple classification levels.
Good point to bring up, Dave. Thank you. Okay, well, Lee, we have another Ansible Tower question, and it's very simply, does Ansible Tower integrate with AD? And if so, can it use CAC-based authentication with AD?
Yep, that's a pretty easy one to answer. Yes, we absolutely integrate with Active Directory or any other LDAP type of authentication methodology on the back end, and we will simply pass through any type of authentication request. So if it's CAC-based authentication, we'll simply take that in on the front end of Tower and then hand that off to AD for credential checking, and then whatever Active Directory reports back, right, we then act upon that. What we do on the Ansible Tower side of things is kind of store permissions for any one of those users, where we map users or groups of users to permissions that we have set out inside a Tower for controlling what those users can see inside of the interface, what playbooks they have access to, what job templates and workflows they can run, and then what pieces of the inventory they can view and kind of see from the management side of it.
Okay, then. Well, on that note, that concludes our Signal Magazine webinar for today. I want to thank our experts for their presentation, and thanks to all of you for joining us. Our presenters will try to respond directly by email to any unanswered questions in the queue. Now, you can link to the archived version of this webinar, along with previous Signal webinars, on the Signal Magazine website at www.afcia.org/signal/webinar. Thank you again, and have a good day.